Hello everyone, welcome to our project video presentation for the embedded system. We have done this project under the guidance of M. Rajashekhar Babu, who is our faculty for this course. And these are the various outlines for the video. Let's talk about a brief system overview. We have come up with the embedded system to give a wireless touch to our existing switch technology. Generally what happen, like to turn on or turn off a switch, you have to go to the switch port and press the button. But here we are using a Bluetooth to create a new link between the user and the electronic device. The user have to simply give the command in his smartphone, and the electronic device will work according to it. We can use this system to monitor the various devices, like if I want to know the fan in next room is turned on or off, I can use it. For the demonstration purpose, we have used the LED which are connected on the breadboard, and the Arduino Uno as our microcontroller. While talking about the system architecture, the hardware involved is the Arduino Uno, which acts as our microcontroller, and a Bluetooth module which is SC05, which acts as a receiver for our microcontroller, and wire breadboards which are used for making connections, and the LED and registers which are used to replace the electronic appliances which we were gonna control to our system. And the software involved is the Bluetooth voice control for Arduino. Actually it's an application which uses a Google APK to convert the speech into a text, which is transferred to our microcontroller, and the Arduino IDE, which is used to run our C program and transfer it to our microcontroller, which is the part of our transcompilation process. While talking about the step-by-step detail of the system, the first step is when the user gave a command, it is recorded in our smartphone and converted to the text by our Android application, which I mentioned earlier, and this text is then transferred to our microcontroller via Bluetooth signals, and these signals are received by our Bluetooth module, by the HC05 module, and then these signals are transferred from Bluetooth module to the microcontroller. Here the actual processing takes place. The text which is received by the microcontroller is something like it starts with the asterisk symbol and ends with the hash symbol. So microcontroller detect the sentence which comes between these two symbols and match this sentence with the predefined command which we have involved in our programming. And if a match is found, then the instruction which are corresponding to it, like turning it off or turning it on, is been executed. This is the circuit diagram for our system. You can see the Bluetooth module and the relay switch are connected to the Arduino. The relay switch are used when we are dealing with the high voltage supply, the 220 volt supply. For our prototype, since we are not dealing with that such high voltage, we're gonna replace the relay with the LED and the register.
Hello guys, I'm Rishabh and I'll be taking over from Devanshu, and I'll be explaining about topics such as UI design, invention details, and the brief description of drawings. So basically you can see the basic UI design. So it consists of a touch button upon clicking on which you can input your voice, and the Google Speech API is activated, which basically takes your voice as input and converts it into electrical signals to be sent for further processing. Then there is a menu option which consists of Bluetooth settings, connect to robot, and app information. So basically Bluetooth settings will take you to your mobile Bluetooth settings where you can turn your Bluetooth on or off, and connect robot option will let you connect to your bot using your bot ID, and app information will show app information, basic app information. So the objectives of the invention, what are the objectives? So the primary objective of the invention is basically to convert the voice input into electrical signals, and which can be used to further operate electrical appliances using your voices. Another objective of the invention is to create a robust system for home appliance control system, Basically, this can be further used for controlling your other electronic devices such as AC, TV, and further on. Another objective is to create a scalable solution for small to medium-sized homes. This can be further included with artificial intelligence, which is a very promising field right now, and many tech companies are working on it. Another objective is to create a solution for users to conserve electricity while in their home environment. Basically, you can just use your voice to activate or control devices, and you don't have to move anywhere or get tired. So now I'll move on to the brief description of our system. So this is the drawing of a basic system, how our system works. Basic. So this shows the schematic view of main components, and so the first component is the smartphone, which is used as our input device to capture user voice signals, and which is processed into text with the help of Google Speech API. This text information is then transferred to the Bluetooth module through Bluetooth signals. After receiving the text by the microprocessor passes the text in small letters, which starts with hashtag and ends with hashtag. The microprocessor is designed in such a way that it compares the input string with a set of predefined strings, and if it is matched, a set of predefined instructions is executed. In the demonstration, which we will give in the upcoming video, the model LEDs are connected to the output pin of the microcontroller, and on receiving the out signal, the current is allowed to pass through the LEDs, which results in the glowing effect. So yeah, that's all. Now I'll be passing on to Suchar Mathur for further explanation of our PPT.
Okay, hi. My name is Suchir. I'll be taking over from Rishabh now to complete whatever's left of the PPT. We'll be looking at the working examples and the circuit diagram as well. Right. So let's begin. Right, working examples. So we made this project with some intention, with an intention that it should have some application in the present, and we can and people who really are people who need it for people who need it for genuine reasons can use it. There are a lot of claims that when you have a smartphone or a smart house or something, people become more sedentary and they just sit around. But that's no. But there's little evidence for that, and the working example that we're looking at right now is also for old people. So basically, seniors. Because of our lifestyles nowadays, a lot of people have complained of back problems, are unable to walk, unable to move without discomfort, and senior citizens especially have a lot of discomfort in moving and in moving and being mobile throughout the day. So simple tasks such as going and getting water, and in this case maybe switching off the lights or putting off the fan, putting off the AC air conditioner because it's too cold and they feel and it's very uncomfortable for them, are challenging. So when we so what we need to do is we need so this system that we've developed here, the Bluetooth module and everything, is a solution in that step, so that people who really need it, people who are in discomfort, can lead a comfortable life. So that's the goal of the technology. So say the fans are too fast, the light is too bright. These kinds of situations are trivial for us today because we are young, we are mobile, and we can move around, and we can put the switch off in our houses. We can switch off any appliance that we want. But they become very difficult, and this is what you can use by simple voice commands through your smartphone. Which is not a simple voice command. Our smartphone can make life so much easier. In nursing homes, we have a lot of nursing homes are genuinely and chronically understaffed. So what you can have is, instead of nurses always attending, because there are more urgent cases for these nurses to attend, simple things like putting off the lights, switching off the fans, raising the blinds of the room. These kinds of tasks can be done through this app-enabled system, and it's a very light system. It's very easy to understand, and it's a very gradual learning curve for anyone who wants to apply this technology in their lives. Right, so that was covering the first example, and the second example is nowadays we have nowadays, since cities are becoming more and more urban, and room and houses, as you've noticed, are becoming very expensive and also smaller, right? So you will want to move your furniture around. You will want to move your you want to keep changing the design and the structure, not structure, but the arrangement of furniture in your house. So it might come to pass that there's a switch which is right under the place where you want to keep your sofa. There's a switch right which is too close to the fridge and you can't reach it. And these things, and there's sometimes it might come to pass that you can't do it's you want to keep some switches for some important appliances, but they're really far away, right? It'll be inconvenient and it'll be impractical to have things like these. So that's why with this system you don't really need any this takes away that constraint, of limited space and limited options, and expands your options such that you can really use your house, and you can really enjoy your house, and you can enjoy whatever little amount, because you spend a lot of money in your house, right? And you get very little floor space and space in your house nowadays. So this is one thing that takes away those constraints and makes life a little more pleasant. I hope it does. And that's one other application we found. Right, so we can also extend this device, this technology, from just simple fans and lights to TVs to air conditioners to toasters to ovens and things like this. Like imagine we don't use ovens too much in India as such, but people abroad, they use ovens a lot. And if you keep your oven really going for too long, you're going to have a problem, because it's going to burn your house down if you don't put it off. So like a lot of people multitask nowadays, right? Because we have very little time. We work 10 hours a day and we come back, and people like middle-aged people have kids to worry about. So you're changing your kids' diapers, you can put your oven off, you can put your lights off, you can put the TV off or on. That's the ease that this system will give. And it'll leverage simple technologies and readily available technologies, which are cheap and and make your life more pleasant and fulfilling, right? These things you can avoid, you can start doing without without many problems. And you can say, like, another working example is maybe regulating fans and regulating the power that the appliance uses, and the mode on which the appliance is. So that's also a good plus, a big plus, right? Okay, fine. So these are some of the working examples of this system, and as you can see, there's plenty to be excited about, because you can use it, and I'm sure a lot of corporates will bring this in a big way, and big tech companies will, right? Right. So let's talk about the pseudocode right now. Let's bring it up here. Alright, so it's a very simple pseudocode. You have a variant. You declare a string. Like, as the Bluetooth system works, it takes all these voice characters, the voice input from you, and it converts in characters. So for that, we declare a simple string variable called voice. Right. Then we have to declare the input and output states of the pins, and we have to. Then the next step would be obviously to collect the string. When we give the voice command, it will be converted into text, right? It'll be converted into text, and then it will be all those words, the set of strings will be formed. Okay, and then if the string, we'll map it to whatever predefined commands that we have. So simple functions like switch off, switch on, lamp off, lamp on, TV off, TV on, right? So it'll match those commands, and obviously the commands will be such that it'll you won't say let us put the TV on. Not right now. It won't accept that right now. You have to say TV on. It should be very specific. So once you compare with these predefined commands, you have your entire system working. And then the last step would be returns either the pin here in this the way we defined it, the way the system that we've made, you turn either pin 2 or pin 3 based on the string by setting the pin high, right? So yeah, that's the pseudocode. Coming to the circuit diagram, I'll just expand this for you in the next slide, right? The circuit diagram I think was covered by Divyanshu and Rishabh before this, so it doesn't really need too much extrapolation expansion and extrapolation on this. This end, as you can see, the Arduino Uno and all the other connections made. Here we have on the, what you can see on the right side of your screen are relays, because you can't connect your screen directly, your Arduino board directly to a 220 volt appliance, right? You need, because that will burn your Arduino and it will cause it will just, it won't work. So that's why we connected to a relay to, what do you call it, to make it safe and to make it functional and operational, and it connects to the rest of the appliances. And yes, that's it. There's just as you can see, there's the HC05 chip there on the top of your screen, the Arduino below it, and all the relays and the appliances that we could connect on the side, and the 220 volt alternating current because of Indian regulations, right? That's it. These are some of the references that we have. Quite a long list, you can see. Right, so that's it from Rishabh, Divyanshu and I. Thank you so much, and if you have any queries or doubts, or if you would like us to build this for you, please contact us again. Like, share and comment on the video. Yeah, and if you can just give us a little feedback and critical criticism of our system, that would be great. Thank you so much. See you, goodbye, cheers. F9?